Okay, your chapter 6 quiz. On the first problem, we're trying to figure out which of the operations were not defined. In order to multiply, and here you see like where I'm trying to multiply m times n here, the number of columns from m, 2, has to equal the number of rows from n, which is also 2. So we can do that multiplication. That's no problem. What we get is a 3 by 2 matrix as the product. Now, if we're going to have to add that to R, then R also has to be 3 by 2, but it is. That's 3 rows, 2 columns. So we can do A. When thinking about B here, I'm going to look first at n times t. And n is a 2 by 2, t is a 2 by 3. The inside numbers there match, so we're good. And the size of n times t would be 2 by 3. We'd like to add that to t, and t is also a 2 by 3, so that one works. Here we have just n involved. So n's a 2 by 2, and if you multiply, and I didn't even write that one down anywhere, but if you multiply n, which is 2 by 2, by n, which is 2 by 2, you get a 2 by 2 as a product. So we can add that to itself. Here's the one that fails. When we try to take r times t, and I've got this one right here, we can do that. We can multiply r times t. R was a 3 by 2. T was 2 by 3. Our product will be 3 by 3. We run into problems, though, when we try to add that 3 by 3 to t, because t is 2 by 3. And to add, the matrices have to be exactly the same size. That one failed. You can check out E worked. So we're good there. The answer's D. On our next problem, we've got a Leontief problem. We're given a technology matrix and a demand vector, and we want to find the production schedule. So here are your two formulas for Leontief models. They're really the same formula. One this is just you take this one and solve it for x, and you get that. We're going to be using this one because we want to find x, which is the production schedule. So we start off by taking I minus a. So that's this 1, 1, 0, 0, 1. That's my identity. Remember, identities have ones along the diagonal and zeros elsewhere. We subtract the technology matrix we're given, and we get this 0.6, negative 0.7, negative 0.2, 0.4 matrix. That's I minus a. We need to find its inverse. Well, to find an inverse of a 2 by 2, we can use our short formula, our quick formula, which is 1 over AD minus BC. Okay, what does that mean? Well, when the original matrix, your 2 by 2, looks like this, AD is that cross product and BC is that cross product. So I took 1 over these two multiplied, my AD minus my BC, and I got that. That actually works out really nice because that's 1 over 1.1, which is 1/10, and 1 over 1/10 is 10. So they gave us a really nice number to multiply. Then what we do is we switch the positions of A and D. So this becomes D and A. And we do the opposites of the minus 0.7 and minus 0.2, which turns in positive. So that's minus B and minus C. So when we multiply through here, we're going to get everything, the decimal just moves to the right when we multiply by 10. We get this 4726. That's my I minus A inverse. So now I'm ready to plug into the formula. X is I minus A inverse times D, and they gave us the D at being a vector 2, 3. So that work is shown here. This is my I minus A inverse times the 2, 3. 4 times 2 plus 7 times 3 is 29. 2 times 2 plus 6 times 3 is 22. The question asks, one of the following is an entry of the production schedule. Which one is it? It would have to be the, it would have to be the 29. And number 3, it says, suppose a system of equations is given in the form A times the vector xy equals 2, 1. And we know what the inverse is. So what we can do to find the value of x, which is my top variable there, is we can multiply on the left side, it matters which side, the left side by A inverse on both sides of our equation. A inverse times A gives me the identity, and the identity times anything, like xy, is just itself. So on the right side now, you have A inverse times 2, 1. So I've just taken my A inverse, which is my 3, 4, 5, 6 that they were given up here, and I'm going to multiply that by 2, 1, which was the vector on the right that we started with. And so now we just multiply, and we just really need this top entry. So I'm going to take 3 times 2 is 6, plus 4 times 1, 4 times 1 is 4, and that adds up to 10. And that's the answer to the problem for x. If they'd wanted y, then we would have taken the second row times the first column to get that entry. Okay, a little quicker one here. This time we've got a matrix B given to us. B is 5, 9, 2, 4, and we want to find the 2, 1 entry of B inverse. So we're doing the same thing we did a second ago. We're just not doing as much with it. We're finding an entry of B inverse. So again, I did the 1 over AD, 5 times 4 is 20, minus BC, 2 times 9 is 18. That's going to be 1 over 2. Okay? And then I switch the position of the 5 and the 4. Now it's 4 and 5. And I change the 9 and 2 to their opposites, so they're now negative. Now I only want this entry right here, the second row, first column. So all I need to do is take this 1/2 that I have here and multiply it by the -2. And 1/2 times -2 is -1, and that's our answer A from our list of answers. On number 5, it says, suppose A, C, and D are matrices and that D times A equals C. Okay, D times A equals C. And we know the inverse of A. Then we want to find which of the following is not an entry of D. Well, okay, if D times A equals C, then I can use the idea of an inverse again. Here's my inverse, and multiply on the right side of A. So you got to multiply on the right side of C also. Remember, multiplication is not commutative. A times B doesn't equal B times A, so it matters which side we multiply on. Okay, when we multiply A times A inverse over here, again, that makes the identity, and the identity times D is D. Now we need on this side to put in that matrix C they gave us. Here is our A inverse, and just do our row by column multiplication. 4 times 1 is 4 plus 35. 5 times 7, that would be 39. 4 times 3 would be 12 plus 20 is 32. That's that entry. 1 times 1 is 1 plus 14 is 15. And 1 times 3 is 3 plus 8 is 11 is that entry. And we want to know which one of these over here is not on that list, and it was choice D, which is 41, is not an element of D. Okay, we've got a matrix A, a matrix X, a matrix B, and we know that AX equals B. So I just wrote down this is A, this is X, and this is D. Well, if we do row by column multiplication, the 1, 1 entry would be C times 1 is C, plus 1 times D is D, and then plus -1 times -1 is +1. Okay, that's this entry here. For the second row entries, over here, and C plus D plus 1 would have to equal 4, which implies, if we need it, that C plus D would equal 3 by subtracting 1. D, for the second row, 2 times 1 gives us the 2. 0 times D is D, so it's gone. and c times -1 is -c. This is the one that's going to give us the value of c, which is what they're asking for. So what we're going to do, 2 minus c equals 0. So c equals 2. I had my sign wrong at the start, but it's positive 2 is my answer. Okay, on number 7, it says find the 2 entries of the matrix C which satisfies C times B equals A times B. All right, well, if I add B over, or add B to both sides, I get that C equals AB plus B. That means the 2-1 entry of C is the 2-1 entry, and I guess the problem changed here. I wanted the 2-2 entry here. So I'm going to change that 2-2 plus B22. Okay, well, let's see what we get there then. This will be the 2-2 entry. So the original problem got changed there to have an answer that showed up on your list. Okay, so with that logic, I need to, for the 2-2 entry, I need the 2-2 entry of AB. So that's the second row times the second column. So that's 0 times, let's see which I'm doing here, 2-2 entry, second row, second column. 0 times 1 is 0, plus 3 times 4 is 12. So this entry is a 12. And B22, right up here, is a 4. And 12 plus 4 gives us the 16. Okay, that's my dog playing with her new dragon toy that we all love so much. Hi, let's put your dragon toy in the closet just for a couple minutes. Thank you, baby. We'll give it back in just a minute. Okay, now, problem number 8, we have another Leontief problem. This one, we're given a technology matrix, we're given a production schedule, and we want the demand vector. Well, we know that x equals ax plus d. So if we solve that for d by subtracting ax, d will be x minus ax. So d is going to equal x, which got changed to 150, minus ax. So I wrote down a and I wrote down x. Well, this is just, again, row by column motion. So this is 0.6 times 100 is 60. 0.6 times 0.5 is going to be 30. And so this is 60 plus 30 is this 90 I've got over here. This is still my x minus ax that I'm doing. So this is my ax way over here. Okay, in the second row, I'm going to take 0.5 times 100, which is 50, plus 0.2 times 50, which is 10. And 50 plus 10 will be the 60 that I have out here. So when I calculate x minus ax, 100 minus 90 is 10, and 50 minus 60 is minus 10. Now that tells us that this setup was not done properly. Put another way, what it's telling us is that we actually, in this problem, if it had been a good problem, in this problem, we are using more in production. A times x is the amount used in production, 60 units of good number 2, then we even had then when we're producing. We're using more than producing, so this wasn't really a valid setup, but you could get the answer, and then the answer to part B there, how much of good 2 was used up? Well, 60 units according to A times X. The last page, nice and easy here. We want the 3-1 entry of M plus R. So all we do is we add the 3-1 entry of M, which is the third row, first column, which is a 3, to the 3-1 entry of R, which is a 5. So 3 plus 5 gives us 8 for our answer. And to get the 1, 2 entry of 2 times m, 2 times m is what you get when you just multiply everything in m by 2. So if we're looking for the 1, 2 entry, that's the first row, second column, the first row, second column is a 5, and 2 times 5 will give us 10. So good luck on your test on Thursday. Study this plus Chapter 5. You've had a couple quizzes over Chapter 5, so hopefully you're in good shape there.